All right, we are up to lesson 6 of unit 5. No new lesson notes, so we're going to get right into the examples. So determine whether each of the following is even, odd, or neither algebraically. So to do that, we're actually going to go back to the previous lesson's notes because that talked about how we can prove it algebraically. So when we want to show whether something is even, odd, or neither, we first check whether it's even or not. So to do that, we have to check to see if f of x is equal to f of negative x. So f of negative x means replace x with negative x and simplify. If you get the same thing as the original function, the function is even. So let's see what happens when I do that with this first function. So I have h of x equals this right here. So what I'm first going to do is I'm going to check h of negative x. So again, what does that mean? That literally means I'm going to take, and I'll use a different color to illustrate it for you. I'm literally going to replace x with negative x. So I literally took x and I replaced it with negative x. And now I'm going to simplify it and see what happens. Well, what happens if I take negative x and I square it? Negative x squared, really what that means, negative x squared, what that means is negative x times negative x. And really, remember, that's really a negative 1x times a negative 1x. And we know that negative 1 times negative 1 is positive 1, and x times x is x squared. So negative x squared is really x squared minus 1. So this will also be x squared minus 4. So when I do h of negative x and I simplify, notice I get literally the same thing as the original function. X squared minus 1, x squared minus 1. X squared minus 4, x squared minus 4. That means that this is an even function. Okay? Once we've determined that it's an even function, we can stop. Okay? We don't have to check whether it's odd or not. So this first function, h of x, is definitely an even function. Okay? Let's try j of x now. So j of x is 2 to the power of x plus 2 to the power of negative x. So I'm first going to look at j of negative x. And so I'm literally means replace x with negative x. So okay. So I replaced x with negative x. So when I simplify this, okay, this will be 2 to the power of negative x plus 2 to the power of negative x. So what do you think negative means? That's a double negative, which makes it positive. So this becomes 2 to the positive x. Okay? Now, when I compare this to up here, it may not look exactly the same. However, because the terms are being added, okay, I can switch the order of the terms and it doesn't change the value. So because there's addition here, I can change the order of the terms without changing the function. And by doing that, notice now it looks exactly the same. So j is also an even function. And we proved that algebraically. Okay? Let's look at our next function, function q. Okay. So Q of x is equal to 1 over x plus x. Okay, so let's try Q of negative x. So in other words, replace x with negative x and see if we get the same thing. Okay, so if I simplify that, I have 1 over negative x. Okay, so that's going to make the fraction negative. So this will become negative 1 over x, because that the 1 divided by negative x will make the overall fraction negative. Plus negative x is the same as minus x. So Q of negative x is equal to negative 1 over x minus x. Well, if I compare this to the original function, obviously it's not the same thing. So this is not even. So we know it is not even. So it's either odd or it's neither of the two. So we now have to check whether it's odd or not. So to check whether it's odd, let's go back to the previous lesson notes. Okay. I have to do f of negative x, and I have to see if that's equal to negative f of x. So negative f of x means to change the sign of each term in the original function to its opposite. Change each term in the original function to its opposite. So in this case, it's going to be negative. In this case, it's going to be negative q of x instead of negative f of x. So negative q of x. So that means take each term in the original function and change it to its opposite. So 1 over x is positive, so I'm going to switch it to negative 1 over x. Plus x becomes minus x. So that's negative q of x, and I'm going to now compare it to this here. Okay? When I compare it to this, those two things are the same. Okay? So those two things are the same, which means that this is an odd function. Okay? So to recap what I did, I initially compared these two things, okay, saw that those were not the same, which means it was not even. So then I compared these two things and saw that those were the same, which makes it an odd function. If it turns out these two things were not the same, then that would mean it's not even and it's not odd, which means it would be neither. So q of x is an odd function. Okay, let's go and look at r of x. So r of x equals 1 over x minus x. So I'm first going to look at r of negative x. So again, that means replace x with negative x and simplify. So replace x with negative x and simplify. So 1 over negative x. Okay, remember, that really means 1 divided by negative x. The 1 over negative x, that's going to make the overall fraction negative. So this becomes negative 1 over x. And then minus negative x. This is a double negative right here. So double negatives become positives. So this becomes plus x. So I get negative 1 over x plus x, which if I compare it to the original function, clearly is not the same. It's clearly not the same, so this is not even. So now I'm going to check odd. So I have to do negative r of x, which means go back to the original function and change all the signs. So 1 over x becomes negative 1 over x. and minus x becomes plus x. Now I'm going to compare these two things. Are they the same? Negative 1 over x, negative 1 over x. Plus x, plus x. They are the same, so this is also an odd function. Okay. All right, we have one more function left. So let's go ahead and take a look at this one up here. Okay, so this one I'm actually going to do over here. Okay, so I have x squared plus 4 and x squared minus 3. So I'm first going to do p of negative x. So that's going to be x squared plus 4 and x squared minus 3. And I'm going to replace my x with negative x. Okay. And I'm going to do the same thing I've been doing. I'm going to simplify. So negative x squared, again, like I said before, that means negative x times negative x. So that's going to be a positive x squared. So this will be x squared plus 4. And this will be x squared minus 3. If I compare this to the original function, are they the same thing? X squared plus 4, x squared plus 4. X squared minus 3, x squared minus 3. This is an even function. Okay, so to recap, h is even, j is also even, q and r are both odd, and then p is even. So that is how we determine whether a function is even or odd algebraically. In the previous lesson, we learned how to do that by looking at the graph, the symmetry of the graph. In this lesson, we learned how to do that algebraically. So that is it for lesson 6.